All right. Hi, everyone. All right. It's raining outside. I like it. I'm from Los Angeles. We don't get rain very often. So let's talk about simplifying the technical stack, the stack. There's something very exciting about complexity. I don't know about you, but when I see that, I would love to be the designer of the system or the operator of the system. There's something so special about seeing complexity, and something that makes me want to work sometimes even in the physical world where you get even more complexity. I remember the first time I saw complex code, I got drawn to it. I'm like, how did they do it? I mean, how many of you wake up in the morning? First, how many of you write code? Do we have people writing code? Some architects? How many of you get up in the morning and be like, man, I'm going to write some really complex code today? Yeah, a few people? All right, this talk is definitely for you. I think there's something exciting about seeing code you cannot write. I remember the first time, I think it was Perl. I saw some really complex Perl. I'm like, wow, the person who wrote this code must be a genius. Turns out I discovered that that's not really how it works. Complexity is much more complicated than just looking at something and being like, I don't get it. There is beauty also in simplicity. This is a manual, it's an automatic manual movement on a watch, and turns out it's actually a very, very simple system when you look at it. You just have a few parts that come together to create a watch, and in an automatic movement, the watch will keep on working forever as long as you wear it. And the system inside that is actually extremely simple. When the military, the US military came together, and then they started thinking about how do we design things as things get more and more complicated. In the 1960s, this engineer called Kelly Johnson came up with this concept of keep it simple, stupid. Now, sometimes people will say that keep it simple, stupid. That's not what he meant. It's just you have to keep it stupid simple. It has to be very simple. And the context in which he did that was that it was designing jet aircrafts. And you had those really big, rockets with people sitting on them that would come in, and they would need to be fixed and would need to be repaired by average mechanics on the field under combat conditions. And they have a limited amount of tools to do that, so they had to make it so stupid simple that with a few tools, you could come and fix a very complex system. And to do that, they figured out we need to start by keeping things simple. And they made that a design goal. And they wrote these few lines. Most systems work best if they are kept simple rather than made complicated. Therefore, simplicity should be a key goal in design, and unnecessary complexity should be avoided. So that's the principle that's still in the US Army when you do anything. So when they evaluate their own design, they look at the complexity of the system, and they know that the goal is to keep simple. Now, before today, I never met anyone who was telling me, I wake up and I'm excited about writing complex code. So I'm glad we have a few people in the room that can explain that to me after. But most people I know don't really want to write complex code. They just want a system that works. They want to design it. And usually complexity comes over time. So what is simplicity? Well, simple means one thing. In algebra, that means you cannot divide more than where you're at. A way of looking at it is when I show you some code, if even without context, you can look at it, you get it right away. There's no surprises. It's probably simple code. There is, though, an anti-pattern to that. And what I mean by that is sometimes you might feel you get it right away, but you might have something hidden behind it. So let's look at an example. On top, we have some Ruby on Rails. And on the bottom, we have SQL. Who thinks the first one is simpler than the second one? Can I see some hands? A few people. What about the second one? Okay, a few other people. Most people agree that the second one is the simplest one. And it's not that simple, but it is simpler because if you look at the first one, you have an entire abstraction layer that will end up generating the same code you have behind it. So you have a very complex system of ORM that would abstract the entire database relationship into something that's slightly simpler, which is a query that will be sent to the database. So it's important to understand that simple and easy are not the same thing. I would argue that if we go back, if I can go back, the first example is probably easier than the second one, but that doesn't make it simpler. And I think this is where it's confusing. And as a matter of fact, I think very often when something looks easy, you might have some hidden complexity that you need to look at, because simple is different than easy. Another example, if I write code and I give it to a junior developer and she cannot tell me what the code really does, I did my job very poorly. This is not a simple code. Maybe she can get it from there's a request that's being sent, but if she cannot really explain what's going on, that's not simple code. The best definition I found, which is not really good, but it's that simple is when there's not a simpler solution. Usually you can break things down, and we go back to algebra. We cannot divide it more than that. And that's what simple is. So there's a reason why simplicity is so important. It's because it gives us the architectural flexibility that we need to build something potentially more complex. You never start a complex system by starting with complexity. You design a complex system by having a simple solution, and as you get more and more simple solutions, the system gets more complex because you might need complexity. But you never start by something complicated, something complex. One other example, and I'm not hating on JavaScript when I say that. JavaScript is everything but simple. It is easy for people to get started with JavaScript. It's easy. There's a lot of things that are really great about JavaScript, but JavaScript is not simple. Whoever tried to implement JavaScript into as a language, it's a very, very complex language. Same thing for Ruby. Ruby is a very complex language. It might be easy to use. That doesn't make it something easy. So this is often the confusion I see between simple and easy. So we looked at patterns, and overall what I hope we all agreed on is that simple is really hard. I think this is true. I think the best engineers who have a lot of experience end up knowing how to write simple code in a way that everybody can get it right away and understand it, and that's one of the hardest things we can do. The second thing is that it's really good news, it's objective. You can see something and you can say, yes, it's simple, no, it's not simple. Easy, it's very subjective. What is easy for me might not be easy for you, and vice versa. However, simple, we can all agree something is simple. And then finally, the reason why we care so much about simplicity is because it will pay off. It will pay off in your design, and it will pay off in just the complexity of your code. And we'll get more into that, and I will share also some examples about what we did. So hard, okay, I already went through that very quickly, but hard, the way I think of simplicity is I love food. I love to cook, I love to eat, and I grew up in France where we have very complex food. The way we build our food is by having mother sauces we put together, it gets super complex. And the opposite of that is Japanese food. If you ever had Japanese cuisine, they try to reduce it to the minimum until you still get this amazing taste, but you get almost nothing else. And this is what's really hard with programming is you need to get to a place where your code is amazing and it does exactly what you want, but it's the simplest it can really be. It's the essence of food. It's your sushimi. Objective. So as I said very quickly, easy is subjective. When you look at simplicity, you can do a code analysis. A computer can tell you this is simple or it's not simple. There's not much to argue with the team about it. What is simple is objectively simple. What is complicated is objectively complicated. And finally, the payoff. There are three things I highlighted. One is that when your code is simple, it's actually a pleasure to work with. It might feel boring, but you can really get into the code and understand what it does, and you can transform it, and you can use it, and you get real pleasure off of it. It's also much harder for bugs to hide in simple code because you can see what it does. And the third thing is really important when you're a company and you start growing or when you have people coming in, it's that it's friendly for new employees and new teammates to come in and actually get the code that is being written. All right, so how do you get your code to be simple? How do you simplify your stack? I have three practices that I try to use as much as I can. Make it a value, set up a process, and then celebrate. Make it a value. What does that mean? Well, it's easy to talk about things, but unless they become a real value of the company, they're just ideas. And I think it's really important that you keep on saying, you keep on repeating things like, Our best engineers don't write clever code, they write simple code. It's important to publish this value if you have some sort of intranet website, or if you have your own engineering blog or something like that. It's important to repeat the value. You might be the CTO, the VP of engineering, the architect, a senior member of the team. Make sure you repeat this value when you do code reviews, when you talk about code, when you look at an example of something else, be like, wow, this third party looks really simple. I actually get what it does. That's something we care about. And also make sure that any candidates you might be interviewing or new employees really know this is the value of the engineering team. We care about simplicity. Yeah, that's what I was talking about. So make sure candidates know about it, make sure you repeat it. If you don't repeat it, you might believe it, but other people might not get it, and especially as the team grows, that becomes important. Setting up a process. So this is very personal to your own organization. I'm not saying you should be doing the same as what we do, but the way we work the process around it is that the culture is only defined by the actions of the team. So the rewards and the punishments of the behaviors will consolidate the culture you're building. So if you want to build a culture around simplicity, you need to have processes that would support that, which feels kind of weird because now a process doesn't seem that simple. But one thing we did at Splice is we set up a concept of an RFC. It's kind of the same thing we do in open source. An RFC is a request for comments. And when any engineers want to architect something or propose a new library or something a little bit different, they need to write a very quick RFC that, I'm just showing you the template, says this is the problem I'm trying to solve. So this is the problem identification, very quick. This is why I think we should be doing that. And we try to also relate that to business goals and to things like that. Then we go into the detail of the design. Why do we design this thing? And again, this really should not take more than an hour to write. I could not really show you a real RFC, but we try to write RFCs as much as we can. Here you explain how the design works, and then you might break it down into different systems if you have different subsystems. Usually we try to keep it so simple in the RFC that you should only have one system. Then you need to talk about the drawbacks. What would be the problem with that? And then you have the alternatives. There might be a few other options. Then we have unresolved questions. Sometimes you might come up with an idea, but you don't really know. You might have some unknowns. You might want to mention that. And this is then put on the calendar, and then the team has a few days to just review and add questions and put comments. And then the engineer who submitted that, she might just merge it, and she might work on the code, everything else, but the team will be able to comment on all of that. There will be a lot of discussions. Usually there's no major, like, oh my God, we're doing it wrong, because we're pretty much aligned. But there will be discussions on, like, have you thought about this? Have you thought about that? And because we value simplicity, a lot of questions come around that, like, maybe there's a simpler solution to do this thing. What's also very nice with the RFC is that it will turn into documentation, high-level documentation of the decision process and what we did. We try to get a bunch every day, and it's kind of like code review, but more from a design perspective. The other things you can do, pair programming. We don't do pair programming, but some people do it, and I think it's very helpful when you want to make sure that your code is simple. If you program with someone else and they don't get it, it's probably because your concept is too complicated or your code is too complicated. You can also do mob programming, as you might have heard some people talk about it during this conference, where you have now 5 to 20 people working on the same code and see if they can all agree that your code is simple. Testing, the speaker just before me was talking about that. If you cannot test your code, it's probably too complicated. There might be a way of simplifying it. Code reviews, also a very good way of verifying that the simplicity of your code is there. You have tools. Most languages have tools to analyze the complexity of your code. You have even services that will connect to GitHub and give you report, Code Climate being one of those. You can do third-party audits. If you're not sure, you can get people to come in and give you a report on that, or whatever makes sense to your organization. I'm not saying those are the things you have to do, but if you set up a process around simplicity, it would get enforced. And this one is a third point on how you implement simplicity. This is the one that was the least obvious to me and took me a while to understand, is you actually need to celebrate. You need to stop and throw a party. So it might be just a Slack party, but you still need to be like, wow, we actually simplified this code. Or look, we have a very simple solution, and people should be proud of it. When you do that, it really sets the value, and it helps you communicate that to the rest of the organization, that you really care about this one value, and it can be shown. You can actually sit down with a project manager and explain how the code works. And they will not write this code, but they will really enjoy the fact that they can get it. Things we do is we highlight the pull requests that we think are really a good example of that. We share the RFCs with the entire team. We talk about it during town halls. And it's usually small wins, but they have such a big impact in the long term because they don't end up creating technical debt. Now, I want to jump onto examples, successful and not so successful examples of applying simplicity concepts. The first one is the Go language. How many people write or know Go? Do we have people knowing Go? Okay, so probably half of the room, maybe a bit less. So when I started Splice, I started Splice about 5 years ago, and Splice is basically GitHub for music and way more, but it's version control for music. We interact with a lot of media files, people back up all their projects, and you do collaboration, and you have a big amount of music data. And I needed something that would help me handle the throughput, and also would be able to build a team. When you start a startup, you know that you have 92 to 98% chances you will be failing. So you don't always want to invest too much, but at the same time, if we didn't have a good foundation, it would be really hard. And at that time, I looked at three different programming languages. There was Go, Scala, and Clojure. Turns out I'm not smart enough for Clojure. It was way too complicated for me to follow everything. I wrote Clojure professionally for about a year, and I realized it was just not for me. Scala was amazing, but nobody could agree on how to write Scala. I worked with people at Twitter, and I was showing them the code. I'm like, this is too much like Clojure, like Ruby. And then I would rewrite it, and like, this is too much like Java. And then I would send it a third time, like, yes, this is good. And I would send it to another engineer at Twitter and be like, no, this is not how you do it. So I figured out that would be a problem. And then I looked at Go, and honestly, Go is very boring. Go cares a lot about simplicity, but it's a very boring language. It doesn't have all this complex stuff that I actually like from an interesting concept. So instead, I decided, maybe I will just use the simpler solution here and see how it goes for a little bit, and then maybe we'll have to rewrite it in a different language. What really shocked me right away is every time I would save, there's this concept called Go font that would reformat your code. So you write your code, you save it, everything gets reorganized, and coming from different languages, there was always people arguing about how the syntax of the code should look like. That was already gone. And then because I could not have like 5 different ways of doing the same thing, even though it was a bit frustrating, it kept my code very simple, and I could really focus on the logic. And then I hired my first engineer. The first backend engineer came in, and I was like, I'm really sorry, I don't really have time to help you, but can you just get familiar with the code today, and then tomorrow we'll pair and we'll go through it. And then they looked at the code, and at 5 p.m., I had 3 pull requests in my inbox. I'm like, well, there's something definitely wrong. And I talked to them, and they were like, no, this is totally fine. I got it. I know what you were trying to do, and by the way, you didn't do a good job, so I fixed it for you. And to me, that was like so amazing. I hired someone who's smarter than me, was writing better code. That's amazing. But 2, they understood what I was trying to do. They understood the logic that I was coming from, and they were able to write those amazing pull requests. And to me, that's when I was like, I can build a team around that, and I hope I will be successful and be able to have people. Now we're 100 people in the company, and Go, I think, is a big part of why we're successful is because we can have new people coming in. Often they don't know the language, and they can learn it very quickly, and they can handle the complexity because we try to keep it as simple as we can. Doesn't mean we're successful, but we try as much as we can. Also, what's nice with Go is the complexity becomes very, very obvious. If you write complex code, people will see it right away and like, why did you do that? This example is less of a happy example. So it was probably about a year and a half at the beginning of Splice, and things were going very well. And we were starting to do remix contests. So a remix contest is when you have an artist giving you an entire track, and you have a bunch of users who take it and remix it and submit back a bunch of results, and people vote for it, and then the best one will get published or something like that. And at that point, I think it was Skrillex was going to drop a track, and then we got into this whole thing. Well, people are going to post so many comments. We need a better system. We're using already MySQL and Redis for caching. Like, I don't know if MySQL can, like, I know it can handle it, but it might slow down everything else. And we went for easy. We chose DynamoDB, which is a document store, And we're like, that can scale, we'll be fine. And we sacrificed simple for easy, and it was totally fine at the beginning. The problem is that it forced us to create a new interface for data. It forced us to have a new SDK to handle. It forced us to have data in a different place. And as the code started growing, we got into a place where we're using one data store in one place and another data store somewhere else. And this data store was only used for a small thing. And while it felt right at the time, it turned out to be one of the biggest mistakes we made. And we still have DynamoDB for one part of our comments because we haven't yet merged it, because there's actually a cost in going back and changing this. We do need to migrate all the data, we need to do all those things, and the engineering team has a lot of other things to do. So this is an example where I thought it would be simple, but really it was easy, and I got this one wrong. And I still feel bad we still use DynamoDB because it was a wrong use case. DynamoDB is a great solution, it was the wrong solution for a problem, and I optimized for easy instead of simple. And the third one is a bit of a weird one because probably most of you don't work on desktop apps. But we do have desktop applications running on the machines. So when musicians make saves inside their workstation, so Logic or FL Studio, Ableton Live, whatever they use, it's the same way that you might be using SVN or Git to make a commit. So every time they save, it creates a commit. So we need to track what's going on the computer. So we ended up writing two different applications. One first in Objective-C. Then when we saw that a lot of people want Windows, we started writing another one in Windows. They were written in Objective-C and in C#. There was also some C code, so we could share it in between the two. But the problem is keeping those two versions in sync was really complicated. It was challenging for us to get to a point where we would have a feature on both sides working at the same time, and then you need to roll out things, and then the UI would be different, and it was really not an easy system to maintain. So we got to a certain point where we decided to invest in redesigning the system. And we came up with this architecture. So we decided to use Electron, but not Electron like most people do. So Electron is usually people end up writing an entire Electron app. We only use Electron for the UI. And we said, OK, we're going to keep JavaScript just for rendering the UI. And we want the UI to be very nice and easy. Easy meaning that the JavaScript developers should be able to talk to the backend like they do already on the front end on the website, but instead they will talk locally to another backend. And they will only handle rendering things, no other logic that UI clicks and rendering. And they will talk through gRPC, which is Google RPC. It's an open protocol that uses protobuf over HTTP2, locally on the machine, talk to a Go process. And at first, because we didn't want to rewrite all the logic, what we would do is we would have the Go code talk to the native code. So here you can see this is the first version. We add this Go bridge that we wrote that was compiled, and that would be linked in the C# code in .NET, and then the Objective-C code on the other side. From there, the gRPC would be calling pinvoke and cgo to talk directly to the native code. So we didn't have to rewrite the logic of the native code, and the UI could be talking directly to the new interface we would be defining. So we redid the entire UI, we shipped it like that. We still had two different versions. And then we got to a somewhat simpler system where now everything is in Go. The front end is talking to the Go process, which is running locally. And then it's also exposing another interface for partners. So a plugin can come and talk to our logic directly using a C++ bindings that gets generated for them. And all the logic, business logic, is implemented in Go. The front end is in gRPC. And even the front end doesn't make HTTP calls. It will talk directly to the Go process, so we can handle offline and online and things like that. So this is an example where we were able to simplify having two stacks. It's still not simple. We have now a bunch of simpler solutions. So within Go, we also have a bunch of other elements, but we have a mix of a lot of simple solutions that come together to create a complex system. So that's it. Those are the three main practices: make it a value, set up a process, celebrate. I'll show you some examples. What I want to leave you with before we jump onto the questions is that your code will change over time. All code changes. I haven't seen code that stayed the same. And complexity builds up very quickly. and the cost of development keeps on increasing. And this is why, as your team grows, you feel you get less velocity. It's because when you start, you don't have any complexity you're building on top of. You start very simple. So keeping things simple would really help. Simplicity is also different than easy. Every time there's a discussion and people start arguing about the code being easy or simple, make sure you're really breaking down into, is it simple or is it easy? If it's simple, we can all measure it and all agree on it. Finally, it's important that teams have a discussion about the cost of complexity debt. The reason is because sometimes complexity might be the right solution. You might not have a choice, but it's important that you talk about it and you agree on that. And if it's a value of yours, you'll be able to weigh the pros and the cons together. And finally, a suggestion is to look at systems that have been around for a long time. And that's not something we have a tendency to do as a community. But if you go back and you look at formats, at technology that have been around for a very long time, there is value in there. It might not be as great today as it used to be, but they manage to have a system that's still in place right now. So, in the world of audio, for instance, I look at the MP3 format, and I'm amazed that we still use it. There's something about it that makes it that it's very valuable. If you look at programming languages, go and look at C. You might not be writing C very often, but there's a reason why C is still the most used language today. And you might not like it, but there's something in the design that made it really stick, and maybe that can influence your own design to keep it as simple as possible, if that's the reason the language is where it's at. That's it. Thank you very much.
Thank you, Matt. Time for questions. Okay, is a program written in a functional language simple? Consider your code will be eventually maintained by an average category M programmer.
That depends on what you think. I personally, as I explained, I didn't stay with Clojure because of that. I think the problem with functional languages is that you have a complexity of following the stack, and I think if you're a really good engineer and if you've been doing it for a very long time, you can probably manage to keep your code simple and functional. This is not something I was able to do myself. So I would consider myself, I guess, less average, and I would say no.
Why JavaScript for desktop instead of a decent programming language if you want nice and simple code? What about Xamarin and Java, FX, etc.?
That's a very good question. I wish you didn't, Peter, I wish you didn't say decent programming language because that's been mean to JavaScript. We use TypeScript, to be honest, but it's basically the same thing. So Xamarin was one of the options we looked at. The real reason in our case is that we need a way of separating the front end and the back end. I wanted a separation of concern, which is a different problem. And our team already knew TypeScript. They already use it in the front end. They already use Angular for the front end. And when we already use Go for all the APIs and all the back end and all the decoders and everything else. So bringing those values together and bringing the team, what the team wanted to use, what they knew, was more important than saying C# is better than JavaScript. This is a difference of what makes sense for your business, for your company, what makes sense for the project you're trying to write, and what you feel as an engineer. I'm not a big fan of JavaScript, but I think it has its place. And when it comes to UI, being able to get our designers, being able to get our front-end engineers coming and work on the desktop app was actually amazing and gave us way more flexibility.
Okay, any drawbacks to using Go?
Yes, like everything else. You have a lot of drawbacks. There are pros and cons. I think I obviously see more pros than cons. If you try to do any type of UI work, I would not use Go. That's a big thing I would never do. I don't think it makes a lot of sense to do it. Some people do it. This is not personally what I would do. Go forces you to also adopt their own philosophy. They only do one thing a certain way. If you don't like that, you might be struggling. So those are the drawbacks I can see. Otherwise, not that many drawbacks, to be honest. It's easy to learn. It's very performant. It runs very well. But it also depends on your use case and the skill set you already have and what the team wants to do.
Okay, what about simplifying the RFC form to just one question?
So funny enough, that's a question that came many, many times. We had someone suggesting to write an RFC to simplify the RFC process. It's an open format. We're trying to change the template as often as we can. We need enough information so people can have a discussion. right? So if you just have one question, the problem with that is you don't end up having a very good structured answer. And if you don't have a structured answer, the discussion will go in all different directions. And we really want people to focus on the real problem and the solution and not really argue about small details that don't really matter as much. So the real thing is, if you look at the summary, this is the one question. You should have, this is the question we want to answer, then you explain the motivation, and then you have the details. And to be honest, as a CTO, I have my own CTO RFCs where I only just ask the question and I propose different direction, and then the team then comes in and decide how to do it.
Okay. Any more questions? Then I guess not. Thank you,
Thank
Matt.
you very much. Thank you. And